This is the for practice problem 6.5 on page 224 of your textbook. And this is our first example utilizing the ideal gas law, which has the formula PV equals nRT. It's basically a combination of all of the simpler gas laws, but in these problems we can solve for or can be given pressure, volume, moles, and temperature. So P is pressure like normal, V is volume, N is moles, T is temperature, and R, we're never given it in a problem. It is the ideal gas constant, meaning that it's always going to be the same value. So the ideal gas constant for units of pressure of atmospheres is 0.08206, and it has the units of liters times atmospheres over moles times Kelvin. So that means that the units that the ideal gas law must be in is that pressure has to be in liters. Pressure has to be in atmospheres. Volume has to be in liters. Moles obviously has to be moles, and temperature has to be in Kelvin. So if you're given one of these items in a different unit, you're going to have to convert in order to be able to utilize correctly the ideal gas constant. Otherwise, your units will not cancel. So this problem, we're going to be using the ideal gas law, PV equals nRT. The problem states an 8.5 liter tire contains 0.552 moles of gas at a temperature of 305 Kelvin. What is the pressure of the gas in the tire? So we're looking for pressure. We're given a volume of 8.50 liters. We're given a mole amount of 0.552 moles. Our R is always going to be 0.08206 liters times atmospheres over moles times Kelvin. And you'll see why that has to be those units in a second. And then it tells us our temperature is 305 Kelvin. So all our units are what they need to be and able to plug in order for us to plug into this equation and solve. So I'm going to go ahead and plug all my values in. P is what I'm looking for, so I'm going to leave that alone. V is 8.50 liters. It's equal to N, which is 0.552 atmospheres, multiplied by our ideal gas constant, 0.08206 liters times atmospheres over moles times Kelvin. And our temperature is 305 K. So now, to get P by itself, we're going to divide both sides by that 8.5 liters. Apologize for the background noise. That's my dog walking around. And now you can see that the units that I need to cancel will, and I'll be left with what I'm looking for. So liters on the bottom cancels with liters in our gas constant. Moles, which I wrote the wrong units here. I apologize. That should be moles. Moles cancels here with moles there, and then Kelvin cancels and Kelvin cancels. And the only unit I'm left with is atmospheres, which is the unit of pressure, which is what I'm looking for. So if I plug all this in, divide everything, I should get that my pressure is equal to 1.64 atmospheres. And that is your final answer for solving this ideal gas law equation problem.